Hey there. So I'm going to just get this last little chunk of video done. I thought it was done. Nope. So enjoy one take of revisiting Simpson's paradox. Okay. So remember those variables that we had, like, well, for you it was nanoseconds ago. For me it was way later, way earlier ago. So yeah, remember those plots where we had a lovely positive relationship if you didn't look too critically? Ta-da! Whoosh. Well, remember how we also forgot about that third variable, that z variable, and how it just utterly reshaped our understanding of this positive relationship? Boom. I hope I timed that right. Boom. So yeah, relationships. That relationship, when you don't take into account plausible third variables, you may be telling the exact opposite story of what's the reality. A classic example of this is the relationship between fires and fire trucks. So, or actually, I like let's back up. The relationship between fire damage and fire trucks. The more fire trucks, the more fire damage. Ugh, we gotta get rid of all those firemen people because they are causing fire damage. Yeah? Are you having that same reaction I am? Good. Because obviously the fire people are not causing fire damage. There's a third variable causing both. Bigger fires. More firemen people are needed when you have bigger fires. And bigger fires cause more damage. Therefore, it's a beautiful fire example. Maybe I will put in special effects. If I don't, that means I was very tired. Or just didn't. But if I did, it's because I'm a magic wizard. This is what happens when we do afternoon and evening recordings. So yeah, Simpson's paradox. Let me spell it out for you. So essentially, it's not considering an important variable when studying a relationship. This is Simpson's paradox. Essentially, it illustrates the effect that omitting an explanatory variable can have on the measure of association between another explanatory variable and the response. This inclusion of a third variable in the analysis can fundamentally change the nature of the result, or not the nature of the result, but the interpretation, and reveal that it's not that firemen cause fires damage. It's that fires in larger size summon both more firemen and create more damage. Ta-da! Oh yeah, and aside, let's talk about group by and count. And then we're done, I promise. And whenever I say then I'm done, what I really mean is I'm really talking to like current antsy me who really just wants to be done recording these videos. Again, this is why I don't record in the evenings. So let's talk about group by and count. So what does group by do? Group by takes an existing data frame and converts it into a grouped data frame where subsequent operations are performed once per group. So recall back to that UC Berkeley stuff, where if we just spit out UBC admit or UCB, UCB, it will just report a tibble with 4.5 thousand rows and 3 columns. But if we spit out group by of our data frame, we'll get a tibble, but it has a grouping variable built in. You'll notice there's that one extra line. Yeah. Cool. And that grouping component really allows us to do some extra subsequent operations quickly. If you find that your tibble's getting slow, you want to use the ungroup function afterwards, because it'll wipe that out and it'll be way faster on your your processor and RAM. So what does group by not do? So it doesn't do really shit other than grouping. It doesn't sort your data or arrange it, as we can see here. Group by, it gives us just whatever data we had. It happened to be nicely sorted, but if you had just a gobbledygook of mess, it would still be a gobbledygook of mess. So it doesn't sort it, it doesn't do anything nice. All it does is group. You have to use arrange if you want to arrange. So it doesn't create a frequency table. It doesn't. So if you want to do that, you need to use count. Oh yeah, look, apparently I anticipated this. So we can undo groupings with ungroup. So here we've got a tibble on this side, the left side for you, maybe. One of the sides, the first side, where we do not have the ungrouping function, where we are applying the count function and then grouping it by gender, and then mutating that to create the proportion admitted as a function of n out of the total. And then we are only selecting out of that gender and proportion admit. We're throwing everything else out. Now, if we toss ungroup on top of that, we will have the same data, but without that grouping component. Cool. Also, fun fact, count is actually shorthand for group by and then summarize to count the number of observations in a group. The only reason these two don't line up is that the group by then summarize has an extra line. But they give the same result because they are effectively doing the same thing. Cool. Also, count can take multiple arguments, which is pretty neat. So you can group by gender and admit, and then summarize that. So you'll get the end result here, versus if you just counted by gender and admit. You get the same thing. It's pretty neat. And it essentially count then ungroups for you. It's pretty nice. So, well, goodness, why do I keep saying the things that are on the next slide? So yeah, count can ungroup after itself, which is nice. And summarize, what summarize does is it peels off one layer of grouping by default. You can specify different behaviors, so you can have it override this using the .groups argument, and there is slightly more information that has been cut off from the slide. So, oops. I encourage you to crawl into the code and find out for yourself what it's supposed to say. Cool. So now we're done. I'll see y'all later. Bye.